Jai Hind everyone, my name is Anju. I am assistant professor in CSIT department in AKGEC Engineering College. So today we will talk about cache memory. It is the topic of computer organization and architecture. So today we will discuss about cache memory. So first of all, we need to understand why do we need the cache memory. If we do have main memory, and as we know, just ignore this one picture here. If we talk about this, then whenever we want to access a data, suppose the CPU is calling a data, okay, and that is residing in primary memory or the secondary memory. As we know, if we want to access something from the secondary memory, first it will come to the main memory and then it will go to the CPU, okay. And the main memory is made up of our registers, chips, RAM, ROM. So the size of the main memory will be huge, as we can say 1 TB or we can say 1 TB. So when we are searching a particular data here, it will take time. Suppose it will take 10 minutes for a particular, or we can say 5 minutes, whatever you want to consider, it will take time. And the CPU is getting that data. Suppose it is calling data X and it is going to primary memory, main memory we will say, okay, and it is fetching that data. It will take a time. Now after completing this operation, it require again the same data, which is X. So it will again go to the main memory and same amount of the time will be taken to fetch the data, the value of the X, and then it will execute. So suppose the same data is being executed 10 times. So the time it is being taken here to search the data and then fetching it and giving it to the CPU and executing, it will take a certain time, and that certain time, if it is asking for 10 times, that certain time will be multiplied by 10 times. So first, if I am saying 10 minutes, so it 10 times it called, it will be 100 minutes, right? But nowadays, or since the computer is being innovated, the main focus is performance. Performance means we will get the output immediately, or the output should take less time in comparatively to previous version. So the first computer, when it was introduced, it was taking to add 2 number in hours, okay. Then we introduced the next version, it will taking half of that time. Then again we improvise the performance of the system, and then it is start taking into minutes. Nowadays it takes only microsecond, nanosecond, this kind of the time it is being taken by the computer. But still we are focusing on the performance to be enhanced, means the less time to be taken to give you the output to the user or anything. So to implement this concept, that means going to the main memory for the same data, we are going 10 times, and 10 times we are searching the data, fetching the data, and then it is being executed. So the concept of the cache memory was introduced. So what it says, suppose we will use a memory, a small memory, okay. Instead of the main memory is made up of 1 TB, so we will make a cache memory which will of 512 MB, okay. And what we are doing with it, the cache memory will be placed in between CPU and the main memory, not after the main memory, between CPU and the main memory. So what will happen, first time when the CPU will ask for the X value, it will go to the cache memory, okay. It is not being there, okay. So what it will do, the cache memory will, then the request will go to the main memory. I'm writing it, writing main memory, okay, and then it will be executed. Suppose it has taken 10 minutes like the previous one, 10 minutes, okay. And then again, okay, 10 minutes. I'm just taking an example when we will place that data into the cache memory. But the system will see the X is being called again and again. It is a kind of the subroutine or a loop, means same data will be called again and again. So what the computer system will do, that value of the X will be placed in cache memory. So there will be some blocks. Suppose this X is in this block. So this block will be transferred to the cache memory. Okay. Now suppose in a main memory there were 256 blocks. How many? 256. And cache memory is of 10 blocks. Sorry, 8 blocks. Now X is being placed here. Okay. Now CPU, if CPU is searching the X data into 256 blocks, obviously it will take more time, because there are 256 options or the blocks where the X can reside. But in a cache memory there is only 8 blocks, so it will take less time. I can say 1 minute. Okay. Now what will happen? CPU will first call cache memory. Yes, there is a X, so it will fetch, and it will take how much time? Only 1 minute. Okay. So the concept is very easy. To increase the performance of the computer system, we use a memory, a small part of the memory, which keep the data which is being frequently called by the CPU or the processor. So what will happen? It will take less time to execute a process. So now instead of searching in 256 blocks, it will search in 8 blocks, which obviously will take less time, and the performance, the output will be generated fast. Okay, so this is the concept of cache memory. Now as we can see, now here we can see cache memory is a fast memory that is used to hold the most recently accessed data in slower main memory. I told you it is being placed between CPU and the main memory. The size will be less, means like 8 blocks. It will search in 8 blocks, it will take less time. Okay, so it will be the faster memory. Idea is simple. Frequently used data which will be called again and again will stay in cache memory. So whenever the CPU is asking for a data, first it will go to the cache memory, and it will take less time to access in comparatively to the main memory. So the output will be generated fast in comparatively to that, and the performance of the system will be increased. Now the main thing on which the cache memory works, I am saying it will keep the frequently used data, but still you will say first 2 time or 3 time means I am saying okay, X is being executed for 2 time, I am keeping it in the cache memory, which I have taken the previous example. So how do we know, and what will be the concept? So cache memory implemented on a concept of the locality of reference. It is very important. The concept on which the data is being placed from main memory to cache memory, that is the locality of reference. There are basically two, temporal and spatial. What happens? Temporal says the same data will be accessed again and again, means repetitive access of same data. So that data will be placed into our cache memory. But there is one more thing. When I'll say, suppose there is an array, there is a for loop. First it will access this one, then this one, then this one, and then this one. So here it says that it is being supposed that okay, it is accessing at the 0 index. There is a higher possibility that it will access at one place also. So two things. A data is being called by CPU again and again, that will comes through the temporal. the same data is being accessed, that will be placed in the cache memory, or there is a high chance that if the data at place 0 is being used, then maybe the next one will be accessed. Okay, so in that case, we place the whole block, means size of a block into the cache memory. So what happens? The cache memory is calling 0. Okay, we know it will be accessed. Now it is supposed to be 1. So when the cache memory is calling index 1, it is also there. So the performance will be increased. So there are two types of locality of reference: temporal, same data being accessed again and again, that will be placed; the spatial, in which it is supposed to that at a certain address we are accessing the data, so the nearby data will be accessed in the future and we are keeping that in the cache memory. So that is the concept of locality of reference, on which with the cache memory works, or on which the data is placed into, or block is placed into cache memory. Now there are many levels also, basically 3 level of cache memory I will introduce. So what happens? As we know, there is a CPU, right? And there is a main memory. Okay, and in between there will be the cache memory. Okay, it is being called, and here it will be this and direct memory if it is not placed into the cache memory. Okay, so what happens? This is the cache memory. The frequently data which is being accessed by the main memory, we will keep it in the cache memory, and then CPU will access that same data from the cache memory, and the performance will be increased, the speed will be increased. But there sometime we need multiple hierarchy, so that we can access, means in a large, we can say supercomputer or the large database where we required many multiple cache memory, so that the performance of huge computers, we can increase their performance also. So there are 3 levels, we are dividing it into 3 levels. Okay, so the first one, which is near to the CPU, it will be the fastest, means here that data will be here which is being called again and again, frequently, recently, on the same time, means at the current time it is being called again and again, so those data will be placed in the level 1. Same thing, the cache memory, instead of 1 we are using 3. Now first one will keep the data which is being executed by the CPU frequently at a present time. Now it could be we know that, okay, means there is a data, we know that we are executing a program, and there is a set of the data which will be called, and in memory, instead of searching in the memory, I want in the cache memory, but it will access after the certain time. First I need a set of the data. Suppose there are 10 set of the data I need, I will keep it here. Once it is being executed, so I, instead of going to the main memory, I knew it that next 10 set data I need after 10 minutes or certain time of the data. So what I will do, I will keep it here. Again, there are the set of the data I know after these two I need this, instead of going to the whole, I will keep it here. So that data set is here. Okay, so what will happen? First it will go here, okay, there it is present, so it will execute. If it is not here, it will go to the level 2. If it is here, then it will execute it, it will send to the L1 cache, and then it will be executed. If it is not at the L2, then it will go to the L3. Those data we need, means there is a large amount of the data which is being executed frequently. So we are keeping them on the basis of their frequent access on the another different level of the cache memory. This one keep those data which is currently being asked by the CPU. This which we know after these it will be called. This set of the data will be called, and then this set of the data will be called, and main memory keeps all the data. We know that. Okay, so these are the multi-level cache memory. So now we will talk about which one will be fast. Obviously, the cache memory which is near to the CPU, it will be faster because here it contains those data which is presently being asked by the CPU. Next will be faster than this one because it is being asked once it is being completed, and then this one. So this is the scenario on basis of what we mentioned the speed of cache level. Now, as we have seen the diagram also, level 1 cache memory, basically it is being implemented within CPU. It is within the CPU and the size will be small, means KB or something. Speed will be fastest because it is near to the CPU, within the CPU, so the speed will be faster. Structure basically हमारा जो होगा split into instructions और data cache. Level 2 ये on the CPU usually dedicated to each core and larger than L1, उससे ज़्यादा large होगा and it will be slower than to L1. Now the third one, it on the CPU die shared among all cores, means it will be shared with all the elements which is being implemented. Largest cache होगा, L2 से हमारा क्या होगा, slower होगा, but still main memory से हमारा ये fast होगा. Now कैसे काम करेंगे? CPU सबसे पहले मैंने बताया था, we will check into L1. If it is not in L1, it will go to the L3, then it will go to the L2, then it will go to the L3. If it not found in all three, then it will go to the main memory. Recently used जो data होगा hierarchy में, that will be sent to the cache memory. जितना फास्टली वो यूज होता जाएगा, मेन मेमोरी में हमने एक x डेटा को है 2 टाइम यूज किया, सो वी विल पुट इनटू द L3. अगेन इट इज बीइंग कॉल्ड 2 more times, then it will go to the L2. If it is being called again 3 times, then it will go to the L1. Means the priority of being executed again and again will be set in a such way that it will shift to the near to the CPU cache memory. Now the main thing comes, cache performance, how it will increase and on which basis we calculate the performance of cache memory. See, I will make a diagram. It is a CPU, then cache memory, and then main memory. Just a moment. Okay. So first, when the processor need to read or write a location in the main memory, first it will check the corresponding entry into the cache memory. If the processor finds the memory location in a cache memory, it will call cache hit. Otherwise, it will call cache miss. Means it is not present in the cache memory. Now I need to find the content. If it is of multi-level, I will go for another level of a cache, or I will go for the main memory cache. Now we need to check the performance. First we will find out the hit ratio and the miss ratio. I will take an example. Okay, cache have X and Z, and it have X, Y, Z, A, and so on. Okay. Now CPU asks for X. First, it will go to the cache memory. First call, yes, cache memory. Means number of call matters. There is a hit. कितने? So there is a hit. 1 hit हो गया. Okay. So the X will be sent to the CPU. Now CPU asks for A. Is it into the cache memory? No. So it will be a miss. It will be a miss, first miss, and it will go to the main memory, and from there it will get E. Again it will ask for Z. Yes, it will be hit. So hit total hit कितने हो गए? 2. Now we need to find out hit ratio. What is hit ratio? Hit ratio is number of hit. How many? 2 means number of hit divided by total number of hit plus miss. And what will be the miss ratio? That will be number of miss divided by hit plus miss. Now one more thing which is very important. As I told you, there is a CPU, there is a cache, and there is a main memory. Okay. When there is a hit, it will go to this hit. Okay. Now it will have its own access time. Means to access the data, it will take 10 nanosecond or 2 nanosecond. I'll call it total access time of cache memory. Okay. But what happens when it is not present in the cache memory? So what happens? First it will go to the cache memory. Okay. So there will be the cache memory access time. There will be. But it is a miss. And what is miss? Miss is equals to 1 minus hit. Or hit equals to 1 minus miss. Okay. So there it is. And 1 minus hit. That is our miss. Or we can write miss also. But if it is not in the cache memory, then it will go to the main memory. So it will be added. That is TM. And this is the formula of average access time of cache memory. This is the formula of average access time of cache memory. Or we can say hit time plus, hit rate plus miss rate multiply, ये क्या हुआ? It is a penalty. भाई ज्यादा टाइम लगा ना, जी इसको आप कैशे मेमोरी का भी टाइम लगा, मेन मेमोरी का भी टाइम लगा. कैशे मेमोरी मिल जाता तो सिर्फ कैशे मेमोरी को चेक नहीं करता, सिर्फ मेन मेमोरी. पर ये तो पेनल्टी हो गई ना, डबल टाइम लग गया. सो वी कॉल इट मिस पेनल्टी. We call it miss penalty. Okay. Hit. I'll write it down clearly so that it will be visible. Hit time plus miss rate into miss penalty. I hope the concept of cache memory will be clear, and the hit ratio, miss ratio, and the average time, how to find it. For today, this is the all. Thank you.